And that is the fact that we have, for example, let me start with this one here. If I lay this down, it lays nice and flat. See it? It's curved. See the chip on it? See it? Nobody wanted a chip lens. By the way, if you're any place where they use overhead projectors, slide projectors, lenses in there. There's lenses in there. This came from a big overhead projector. That's the one that, you know, that they put a piece of acetate on. All right, curve. Curve on top, flat on the bottom. Now look at this. See how that wiggles? That definitely tells you it's curved. All right, this is called a plane side. It's plane or plano. And this side going up would be called convex. All right, so that is convex. Convex is a lens in which we have curve on top and flat on the bottom. That's a convex. Now we have another lens, and this one sticks out on both sides. Okay? So when it sticks up like this, it's called convex. Since this sticks up on both sides, it's called, you ready for the scientific? This is awesome, huh? Double convex. Duh. Okay, so it's double convex. This was plano on one side and convex on the other. Or they can say single convex or plano convex. You develop your own vocabulary. But of course, check your dictionaries and all. And in science, to be able to communicate with each other, you do have to have your proper vocabulary. So if you tell someone here that you have a convex lens, they'll know what you're talking about. And if you happen to mention or forget to mention what's on the other side, in most cases it won't make any difference. Now these do not match. In other words, if I put these to my eyes, see it? They don't quite match. One seems to be, shall we say, a little better than the other. Do you know the thicker that the convex curve is, the thicker part of it, the more powerful it is, stronger. And if it's not very thick, which this one is not compared to this, then it's not nearly as strong. It's somewhat weak. Now that does not make this less important. See, they design these to fit the need. If you want to develop a telescope, usually the lens on the very outside of it is the one that's built that way. Okay, now there's one more. I like this one. I'll put it to my eye. You ever seen people wear glasses like that? Where their eyes look much smaller? Take a look at that. Let me put it down here for you. Okay, it's flat on the bottom somewhat, but look when I take my finger here. Look, I'm going down in the valley. See it? That's like going, as I remember this, don't mean silly. You go into it like a cave, so this is called a concave. Concave means it goes inward. Now what's neat about a concave is simply the fact that you have things become smaller. Let me just put this here. See how that's smaller? Let me put the other in front of it, this one. See how it becomes larger? See it? And this one's smaller. Pulled away, it's even smaller yet. Look, I got the whole package in there. Do you know that the cameras that are looking at me here, they've got a concave lens somewhere in there to help you see more. In other words, to get a wider space. And when cameras are zooming, that's a lens that's moving. And they're moving, most likely they're moving the concave. You see, if you put this one with this one, concave with a convex, and you go like this, you actually can create your own or make your own telescope. All right? Now you go to the mall. They have these stores where they can, they sell these. Maybe they have a chipped one, the one that makes concave, makes your eye look smaller. And then again, you can always go to these stores that sell nature items, and they might have a collection of optics. Don't be disappointed because they might be very, very small. In fact, they might even be plastic. That's what happens also to the price of equipment, is how much does it cost? All right. What we need to look at, now I'm looking around trying to find out what's next here to pick up what's next. Mirrors. This is a very expensive mirror. This probably sells for about $20 or $30. Why is a mirror so expensive? It's because this is what you call a highly reflective mirror. In other words, it's extremely high quality. But I want you to notice those little dots all over it. That's not dirt. That's the back coming off. I have handled this mirror too much. In other words, I should have left it alone. You see things in here. You want to see what the camera looks like? Somewhere around here. But anyway, I've handled this mirror so much that I have caused the backing to begin to flake off a little bit. So this is not such a highly reflective mirror as it could be. So that's one mirror. See this thing sitting here? It's on a little tripod. Look at it. This happens to be a mirror from a telescope. Oh yeah. 1 inch is $100 for these mirrors. This happens to be an 8-inch mirror. That's $800 sitting right here. Now it does need to be silverized. In other words, they put silver on the back side of this thing. Yeah, this is a fairly old mirror. And see the little dots on it here and there? Those have to be taken off. This sits at the back end of a telescope. That's what this is all about. That's a reflecting telescope. When you take a look at my series on astronomy, we'll talk more about reflecting and refracting. But look at this one. No, this is not a gun. This is a telescope that has lenses in it. This is called a refractor. You want to see the lens? I forgot to take the cover off. Keep the dust off. See, there's the lens in there. See it? This is a refractor. Now, the refractor, if you want to get a good one, even though it's like this, it's got to be at least 2 inches or more in the front. 2 inches or more in the front. Less than that, it's a toy. More than that, you're in good business. Now, these are a lot more expensive. The reason for the expense is that there's a lens in the front. There should be a lens right behind it in the front. There may be one here. There may be one down in here. And there surely will be something on this end. A lens over here that comes out, and you can even change them. Change the lenses for more power. These are more expensive because, you see, making a lens is more expensive, more difficult, more precise than making the mirror. Okay, so this is called a refractor. That uses lenses. Reflecting, or reflector. The reflector is a telescope that has the big mirror on it. Okay? Got some other goodies here. Do you know anybody who does any welding? These are awesome. Look at that. Just a chunk of nothing. These are welder's glass. You know, puts in that little window when he does his work here, you know, the welding. And these are called just the welder's glass. You can hold this up to your eyes and look at the sun, and all you will see is a very faint little ball for the sun. This is used for eclipses. Anytime there's an eclipse, please see if you can get a hold of a welder's glass. Okay? So the welder's glass, and I keep them well protected and wrapped. So every time I have an eclipse of the sun, that's what I do. I go out and start looking for whatever I need to look for. Okay, now we have something of interest to some people. In a slide projector, we have a piece of glass. It doesn't look much like anything, but it's coated with oil. Yeah. You see, when heat hits this piece of glass, it disperses, it spreads out the heat so that it does not cook the picture in the slide projector. That's no real problem, is it? Okay, another one. I got everything in here. Once upon a time, oh man, I got cool shades, right? Once upon a time, they used to have sunglasses that we would call polarized. Polarized. Polarized simply means that if you can take these two, let me put it over here, and see, one, the light goes through it. Let's try it down here. We'll look at this one here. Okay? And I'm going to put this yellow piece right behind it. I'm going to put this polarized piece in front of it, and I'm going to turn it. You actually can see through a little bit. This works better if you've got light going through it, but we don't need, see? It gets darker, and it gets lighter, gets darker, and gets lighter. Let me try with this piece. Those are glass, and this is plastic. Oh yeah, much better. See it? See through it? Now watch when I turn it. Boing, gone. In the old days, those of you who wear polarized glasses, you would tilt your head back and forth, and the sky would get nice dark blue, and other times it would be a light blue. So these would actually block out the light. What's neat about this? Polarized is lines. A light travels in lines, this way and that way. So polarized glasses would let the lines come through only one direction. And when you put the two together and turned it, it blocked them both out. And they thought that was really great for the eyes because this kept the light from going through. Now we know that's not it. You have to have UV ultraviolet. Okay, in closing, let me remind you that you need to go to, don't be a pest, but I will tell you I have had kids go to these optical places that repair microscopes or cameras, and the kids have walked out with about $300–400 worth of lenses. How can that be? Well, you know how computers become outdated and TVs become outdated and cameras? So do cameras and binoculars. And the lenses you put on cameras, sometimes the camera isn't made anymore. But go in and see what you can find. Go to the shops that sell, make these and sell them to you within the hour or so. Ask them, tell them you're, working on a science project, which is nothing more than making little telescopes or whatever. But get out there and start shopping around. Don't buy, look first. And then if you have to go to one of those science stores, then you can pick up something fancy like that. Okay. We'll be right back for part 2.